All right, where does gas hydrate occur? And what is gas hydrate? Gas hydrate is an icy mixture of water and gas that occurs below the surface. Um, it's usually methane, and some occur on land in the form of permafrost. It may contain twice the amount of the total carbon as all other fossil fuels. Okay, so gas hydrate is a huge deal. However, it's all frozen and we do not have access to it. We don't know how to use it just yet. It's difficult to use so far, and the methane is a greenhouse gas. So if all of this gas hydrate were to melt and be released into the atmosphere, it would rapidly change our atmosphere to much higher methane content in the air and therefore much warmer temperatures because it is a greenhouse gas. Where does it occur? So if we take a look at this map, we can see the red dots where it occurs. It occurs on the ocean floor where it's cold and deep along continental margins. What is oil shale? It is oil trapped within small pore spaces of clay-rich material. It formed from algal matter in lakes, lagoons, and estuaries. This map shows us where it's found. So, large reserves are found in the western U.S., but they're also found in Australia and Canada. The most important sources are found in the Rockies on the Colorado Plateau. This area formed as a large organic-rich Cenozoic lake. To extract the oil from these tiny pore spaces, though, is very difficult. So they either mine the shale out as a rock and heat it up to get the oil out, or they're developing methods where they can heat it in place. So the problem with oil shale and utilizing it as a fuel is that it requires so much energy to heat up the rock enough to extract the oil from it. It doesn't really make sense. So when you see us going after oil shale as a serious source of petroleum, then you know we're really in trouble, because it really, with the technology we have right now, it just really isn't worth it. It's not a smart fuel. Alright, this map is showing us the locations of the world's largest deposits of tar sands. Tar sand forms when oil seeps into unconsolidated sand or consolidated sandstone. The bacteria degrade the oil into a thick sludge. So they're breaking down the oil. They eat up the oil, basically. And what's left is a very degraded oil. The world's largest reserves are found in the Orinoco Basin in Venezuela and the Athabasca Basin in Canada, each with 1/3 of the world's tar sands. Tar sand may represent 2/3 of the world's oil supply. So 2/3 of the world's oil supply is in tar sands, and this as well is not a great fuel. It's very degraded, basically. The bacteria eat up the lighter oils, and what's left behind is the heaviest oils and all of the waste from the bacteria. So not ideal stuff. How do we explore for fossil fuels? First of all, we examine a sequence of sedimentary rocks to see if they represent the right environments for the resource. So if we're looking for oil, is it an ancient marine environment? If we're looking for coal, is it an ancient swamp? So we want to look at the geologic history of the area to figure out, is this an area that could have formed um, the resource we're looking for in the first place. And then after that, once we decide that, we want to identify structures that trap oil. So favorable structures such as folds and faults. We also want to identify unfavorable rocks like granite or histories of high-grade metamorphism, meaning that area underwent very high temperatures, so even if you had oil there at one time, it has been burned up, most likely. You use geophysical surveys, especially seismic surveys, to try and understand what's below the surface. Okay, so again, we look at the layer sequence. Does it make sense that we should have oil or coal deposited there based on the environment that used to be there? We look at the structures. Are there favorable structures? Is there a fold for oil to accumulate under? Do we have a reserve rock and a cap rock? That sort of thing. And then once we've established those two things, then we can use seismic reflection studies to see what's going on below the surface. So these big trucks go around and basically make little earthquakes. They are these huge trucks that just thump on the ground, sending seismic waves through. And then you can read the way that the waves move through the subsurface to see if it's moving through fluids or oil or what type of rocks are there. It's a very useful